continuing. There's nothing new today. It's just harder questions. So these are in brackets. The brackets, the only thing that it means is multiplication. So when we're multiplying the same base, we add the exponents. But what happens if we're multiplying 3 times 2? What do we do with that? We just get 6. That's right. Okay. R to the power 4 times r to the power negative 2. We add the exponents. What do we get? R to the power 2. S to the power negative 3 times x to the power negative 5. What do we get there? S to the power negative 8. We should not ever leave our answer with negative exponents. So this is not acceptable. So what do we do with that? We slip it to the denominator. So my final answer is going to be 6r squared over s to the power 8. Does everybody see? That's my final answer. Okay, we'll do a couple more here. Do you see if this is 4 over 2, that's really 4 divided by 2. This is not the same base, but we can actually divide it. Or in some cases, we're just reducing the fraction. So what's 4 divided by 2? What happens if the 2 was on top and the 4 was on the bottom?
I don't know.
No, it wouldn't be negative 2. I'm sorry? What do you mean flip it? What I was saying is, what happens if this was 2 over 4 like this? What would my answer be? It would be a fraction, 1/2. So the 2 would be on the denominator, right? A 1 on top, 2 on the bottom. Okay. M to the power negative 2 divided by m to the power 2. This is how you're going to get tricked on your quiz. You might want to write it out. What are we doing with these exponents because it's division? Subtract. So really this is negative 2 subtract 2. So what do we get there? Negative 4. So m to the power negative 4. I cannot leave my answer with negative exponents. So what do I do with that? Very good. Okay. Now, negative exponents are different than negative numbers. Does everybody have that straight in their mind? This negative 6 doesn't become magically positive 6 if I put it as a denominator. Does that make sense to you? Negative 6 is always negative 6. You can't change a negative number into a positive number unless you're multiplying it by a negative number, right? Negative times negative, then it'll become a positive. So what do I do here? Negative 6x to the power negative 5. What do I do there? What's not acceptable in this? The negative exponent. The negative exponent is only going to the x, so how do I make it positive? That's where I slip it down to the denominator. So I'm going to get negative 6 is still going to be on top. What's going to be on the bottom? X to the power 5. And sometimes that's all you do. Okay. Same with this one. Do you see negative 7? It's not a negative exponent. It's negative 7 no matter what. No matter what. So this is still negative 7. What's not acceptable in this here? Yeah, m to the negative 5 cannot be left there, so we need to slip it down there. So what's my final answer here? Very good. Okay. What do we do when we have this scenario here? Do you see nothing's new here? We're just kind of doing everything kind of mixed up here. What do we do here? Yes, so anytime you have a negative exponent, if it's a fraction, then you flip it, right? And that makes it positive. If it's a numerator, it becomes a denominator and becomes positive. Or if it's a denominator, it becomes a numerator, it becomes positive. So we get 7 over 5 to the power 4. Does this say evaluate? Simplify. Your answer should contain positive exponents only. I'm thinking that we need to actually find 7 to the power 4, which is a little bit gruesome, but that's okay. What's the fast way of finding 7 to the power 4? Okay. So 49 times 7 is 63. And so that's 343, and then times 7 again. So that's 21, 28, 30, 20, 2401? Okay. 2401 over 625. Yes? Okay. Uh-oh, how do we do F now? So this 2 here not only goes to the x, it goes to the 3 as well. So what are we going to get out of that? 3 to the power 2, x to the power negative 8. We cannot leave this like this, so we slip it down. So what's my final answer? 9 over x to the power 8. Yes? All right. How about I give you a chance to do the rest of this page? I'm going to leave the next page to do together because it's a little crazy. But do the last 3 or 4, sorry, do the last 4 and then we'll go over it, okay? Okay. You need to look at this as a fraction. 3 over 6 reduces to 1/2. Yes? We're good with that part. Then the thing I keep on seeing people making mistakes when they use the exponent laws, they're just putting the base wherever they want. When you use the exponent law, it stays on top. If it happens to have a negative exponent, then you move it to the bottom. So this is 4 subtract 7. So I get negative 3. So this is x to the power negative 3. Do you see it's on top? Now I'm going to move it to the bottom. So my final answer would be 1 over 2x to the power 3. Do you see that? Again, this is a fraction that can be reduced. Negative 10/15. 5 goes into both of those. Negative 2 over 3. Yes? Negative 2 over 3 is not an exponent. It's legit to stay where it is. It's positive 1 exponent for 2 and a positive 1 exponent for 3. It stays where it is. This negative just means the fraction is negative, right? So then we have a to the power 4 divided by a to the power negative 5. So that is 4 subtract negative 5. What do you get there? You get a to the power 9. Then you have b to the power negative 5 divided by b to the power negative 2. So this is negative 5 subtract negative 2. So what do you get there? Yes, b to the power negative 3. Now you look at your answer, and because this is a negative exponent, we slip that down. Final answer, negative 2 over 3. A to the power 9 stays there. B to the power 3 goes to the bottom. So there's your final answer. Okay, let's move on. Too many people are doing too many steps at once, and that's how you run into difficulty. So the first thing I would do would be to make this 5 go to the exponents with the power to the power rule. So this is really 2 to the power 5, r to the power negative 15 times 2 to the power 1, r to the power negative 2. I highly recommend, if it doesn't have an exponent, put the 1 there so you remember now when I'm multiplying the same base, I add, because I saw a mistake for a few people. They didn't add 5 and 1 to make 2 to the power 6, r to the power negative 17. I cannot keep my answer like that, so what do? Yes, I'm going to move the 17, or the r to the power 17 to the bottom. And what's 2 to the power 6? 64 over r to the power 17 as my final answer. Yes? Okay, again, here I would do the power to the power rule first. So this is 3 to the power 1, x to the power negative 3 over 3 to the power 2, x to the power negative 4. Did everybody see what I did so far? All I did was the power to the power on the denominator. So now I'm going to do the exponent laws. These are the same base. It's not a fraction. It's the same base. So I'm using the exponent laws. 1 subtract 2. What do I get? Negative 1. So it's going to be 3 to the power negative 1. Negative 3. I'm going to write this out. Negative 3 subtract negative 4. What do I get there? Positive 1. So x to the power positive 1. Can I leave my answer like that? No, I cannot have this like that. So this slips down, and my final answer is x over 3. How'd we do there? It takes a lot of practice. Like, I suggest that you do every single bit of homework on 4-6 to get this going. And like I said, I'm going to go back to yesterday's where we had those fraction ones because it seems like we forgot how to add fractions. Okay, so let's do this one. Woo! Wow, look at that, eh? So there's not the same base. 4, 2, 4, and 2. There's some the same base, but really there's not. So what I would do is I would just go, and I don't know why there's brackets, really. The brackets don't mean a thing. What's 4 times 2 times 2? Or you can cancel the 2's. It's up to you how you want to do this. How do you want to do this? So you want to go 4 times 2 is 8, times 4 is 32. M to the power negative 2 times m to the power 7 times m to the power 1. So what would I get for an m there on top? Negative 2 and 7 is 5, and 1 makes 6. Everybody gets 6 there? N to the power 3 times n to the power negative 1. So I add 3 and negative 1, I get n squared. Now the bottom I'm just going to rewrite. And then I'm going to do that. And I think, like I said, I think most people are getting the wrong answer because they're doing too many things at once. So does everybody see this is not the same base? This is just a divide. 32 divided by 2, right? What do we get there? 16. M to the power 6 divided by m to the power negative 2. This is subtract. 6 subtract negative 2. What do I get there? M to the power 8. Remember, our answer is always going to be a numerator when I do the exponent rules. And then n to the power 2 divided by n to the power 2. This is 2 subtract 2, which is 0. Do I usually write n to the power 0 there? No, that's just 1, right? So this is our final answer then. Yes? Yeah, I wouldn't write n to the, sorry. So my answer was 16 m to the power 8, n to the power 0. N to the power 0 is not really, like, you don't usually write that. That's not simplified. Because n to the power 0 is equal to 1. So really this answer is just 16 m to the power 8. Do you see that? Okay. Okay, so then we have another 0 in there. So you can get rid of it, really, but we can just keep it going. It's up to you. So again, I would do this one step at a time. I would distribute this negative 3 into all the exponents there, right? So then I get 4 to the power negative 3, v to the power what? 0, w to the power negative 9 times 2v squared w 10. See, now the problem is my 4 to the power negative 3 and 2 are not the same base. So what am I going to do? Well, I have to move this to the bottom. Yes? So 2 is going to stay on top. 4 to the power 3 is on the bottom. Okay? Is everybody good with so far what I did? Now we're going to do the exponent laws for multiplying. V to the power 0 times v to the power 2. We add the exponents and we get v to the power 2. Because really this is like having nothing there. We just have v squared, right? Okay, and then we have v to the power negative 9 times v to the, sorry, w to the power negative 9 times w to the power 10. What do I get? Yeah, w to the power 1. And so the only other thing I can do here is what? Evaluate that. Who knows what that is? 64. So 2v squared w over 64. Is that a legit answer? No. What do we have to do now? Simplify it. This whole thing was simplified. So 2 over 64 is not simplified. What can I reduce that to? Yeah, you can put the 1 there. You don't need to have a 1 on top. Only if you need it as a placeholder like we did for question number G. I needed that 1 on top, right? Because there's nothing else left on the numerator spot, so you had to have a 1. Would you get marks taken off if I put a 1 there? No. You can have the 1 there. It just looks kind of weird, though. Okay, so that looks better. Okay, do you guys want to try the last one, and then I'll go over it? Yeah? Okay, and then I'll come up with some fractional examples, okay? All right. This is 2 to the power negative 3, a to the power positive 3, b to the power positive 15, c to the power 0. Really, I could not even write this c there for all I care. 2 to the power 1, a to the power negative 1, b to the power 1, c to the power 1, over, did you know that you could rewrite 4 as 2 squared, and then you have the same base? Did anybody think of doing that? You could write 4 as 2 squared, and then you'd have the same base. Do you want me to do it that way? Okay, I won't then. A squared b to the power 3. Okay, so now I'm going to do the top. I'm not going to do the bottom yet. I'm just going to manage the top. So what do I get for 2 to the power there? Negative 2. What do I get for a? A to the power 2. What do I get for b? B to the power 16. What do I get for c? C to the power 1. Okay, on the bottom I get 4a squared b cubed. Okay, so now I cannot do anything with this the way it's written, right? I can do, so I'm going to slip this to the bottom. Okay, what do I get here when I do a squared divided by a squared? They cancel out. So I'm not even going to write a to the power 0. I'm just not going to write it, right? And so then what do I get here for b to the power there? B to the power 13. And then if you want, you can put c to the power 1, or you could just leave it like this. And then this 2 squared is going on the bottom, and this is still 4. So what do we get at the bottom there? 16. Did anybody actually get the correct answer here? B to the power 3, c over 16 as your final answer. Good job. Okay. That was a hard one for sure.